go ahead with your presentation.
Okay, so we will be discussing the Diablo16 embedded graphics processor, and towards the end of this webinar, we will be discussing also one of the products, what is Diablo-based. This is this micro LCD 7GBP. So first, let's start with the Diablo16. Hold on.
Is there any problem, Danny? Danny?
Yeah. My slide.
Is there any problem, Danny, or we can go ahead with the presentation?
Yeah, I'm just can you see the second slide, please?
Excuse me, I can see the main page of your presentation.
When it's not transparent.
But I cannot see the other pages. Is there any problem which I might help you with?
My presentation is not full. It's not transferring to the next slide.
Maybe you should try share it one more time.
So, okay, sorry for that, folks.
Okay.
So can you see my second slide? So what is actually the Diablo16, and what's the difference between Diablo16 and the Picasso? So how is it different from the Picasso? Well, this Diablo16 is the latest addition to the 14 system processor range, and compared to the Picasso, it has more power, around more flash, more features. This is a custom embedded 4D graphics controller, and it can interface with many OLED and LCD display panels. It has powerful features, makes it a simple solution for many LCD and OLED displays. It's powered by a highly optimized top-core virtual engine, which we call Leap. It's actually a proprietary for the system, and it's a high-performance virtual processor. It can execute compile for the real programs to tackle many embedded graphics applications, and it has a comprehensive set of I/O features. It has also interfaces to SPI, I2C, stereo, digital, and analog. So let's look at the interfaces and the features. The display interface. The Diablo16 supports LCD and OLED displays with an 80 series 50 wide CPU data interface. So everything what has something to do to control the LCD, like the read, the write, reset, chip select, it's all there. You can see Here it's the write cycle, and here's the read cycle. So this is our Diablo, and it has also control for the DC to DC converter for the backlight control. Here you see at the left side the logic table, what must be the state of chip select, the reset, read and write operations. So it's straightforward. The Diablo16 generates all these necessary timings to drive the display. So another interface is the serial interface. It has 3 hardware asynchronous serial ports that can be configured in a variety of processors. These are all configurable and can be mapped to the different IOs, GPIOs. EX0 and RX0 is, however, dedicated and fixed to 33 and 43, and they are used to communicate with external serial devices after they are used for programming. So they can be used for communicating with other serial devices as well. So, but this is fixed, and TX1 or COM1, TX2, RX2, TX3, and RX3 are all mappable. You can assign to PA0, PA1, for instance, RX, and PA1 to TX1. Similarly, you can do that to COM2 and COM3, or any of the pins. There are not all the pins, of course, are capable of being configured that way. However, most of the GPIO pins can. So it gives an ease of use, especially if you are routing it on a board. So you can interchange pins, whatever is convenient for your PCB or for your end application. The serial communication primary features is full duplex 8-bit data transmission and reception. So we have the data format of 8 bits, no parity, one stop bit. So this is fixed, and we have independent baud rate selectable from 300 baud up to the 603 baud. Single byte transmit and receive for a fully buffered service. You can select that. The buffered service feature runs from the background, capturing the buffer in without the user application, having to constantly poll any of the serial ports. So optimize greatly your application. They do not have to poll the serial ports, especially if you use the buffering service. So increase the application service the other time. And the interface is the SPI, I believe. Like by the Picasso, we have one of the SPI interfaces that is dedicated to the micro SD. The Diablo has several SPI interfaces. SPI 0, it's assigned to the micro SD. So these are the signals, and this is micro SD signals, and all in all, you have 4 SPI channels. Also, okay, the SPI compatible SD micro SD cards must be used. And we are using this protocol. We are not using the normal SD protocol, much as we want to, but this, since we have limited resources, as far as having this all embedded, so we suggest that the micro SD used must be SPI compatible. So it's also important that the path partition It's always the first, and well, it can be up to maximum size permitted by FAT16. For Windows 7 systems, it will format up to 4 gigabytes. Windows XP will format FAT16 up to 2 gigabytes. But if you are using the command prompt, it can go up to 4 gigabytes. So the 3 other SPI ports, as I have mentioned, are also mappable. That means you can assign SPI 0, SPI 1, 3 signals, for instance, to any of these GPIO pins. Similarly, you can do that as well with SPI 2 and SPI number 3. Please note that all 3 SPI channels are master only. They cannot be configured to display at this time. You have also the I2C interface. Much the same way as the SPI, there are 3 user configurable I2C ports, I2C channels available for mapping, and they are also all masters only. Notice here that same like the SPI, you can assign any of the channels. This is channel 1, for instance. You can assign it to any of these things. Channel 2, similarly, and channel 3. Except PA14 and PA15. So now with the GPIO, there are 16 GPIOs available to the user. This provides the flexibility of individual bit operations along with serving collectively for byte-wise operations using the bus function. So you can assign it as an input only or as an output, okay, up to PA13. At the same time, you can use some of the GPIOs for the special signals like the bus read, bus write, and this for the analog, for instance, we have only assignable for PA0, PA1, PA2, or PA3. So, okay, let's go to the ultimate function. This is a feature of the Diablo, what is not in the Picasso. Some of the GPIO pins can be used as pulse outputs. So that means you have from PA0 up to PA9, they can be used to output pulses. There are several pins also that can output pulse width modulation. Some of them has also the counter function. That means if you have pulse input on PA4 or PA5 up to PA9, it internally has a counter, and you can use that for logging some activities or events external to the processor. Another feature is the quadrature input. So PA0 up to PA13 can do that. That means you can input quadrature signal, especially if you are controlling motors or other devices that uses quadrature signals. So it's a convenience. You can assign that to any of these things. So not all pins, however, it's very clear that not all of them can be assigned to this alternate pin function. But at least we have several of the pins available for this special function. So this is internal the architecture of the Diablo16. The Diablo16 is not a conventional microcontroller, and it doesn't use the conventional microcontroller architecture. It has at its core the EVE, soft-core extensible virtual engine. It's like having a processor over another processor. That means you will not be programming and talking to the chip, the low-level functions, but to high-level functions, which is actually 40GL. 40GL is the 4D graphics language. What is specially made for all these graphics, there is a processor, and it has it allows rapid application development, and the syntax and structure is defined using elements of popular languages such as C, BASIC, Pascal, and others. So for those who are familiar with that, it's easy to program in 40GL. So let's take a look at some of the features internal to the processor. One of them is the flash storage in the RAM. Here on the right shows that you have there system flash. System flash takes care of the PmmC loader, the PmmC internal function, the display driver, internal font. You have also the user flash. So this is actually, if you compare that with the Picasso, you had only one, and even it is less than half of one of the banks. Okay, let's take a look at the systems flash. So there are four main sections of this, which is contained inside the systems flash register. You have the PmmC loader, which can be thought of like a bootloader, actually. And then you have another section of it. It's the PmmC and internal functions itself. The PmmC file it's actually the low-level microcode information, and which is what I was explaining earlier, the analogy of that soft silicon, which defines the characteristics and functionality of the device. So for any type of display, you have a particular PmmC file. The display driver section contains the initialization and parameters associated with the particular display that is to be connected to the Diablo16 processor. So the initialization and all the other parameters necessary for the display contained in this section. Within the systems flash is also a section for the storage of internal fonts. So this is what is inside the systems flash. So now we go to the user flash memory map. We have 6 of it. They can be utilized by the user to store application code or data, and to be used by the display, or can be used also for storing data for sending to external devices over the comms port. So each of the 6 banks, each of which is 32 kilobytes in size, 32,750 exactly, and definitely it's over 12 times the flash capacity of the Picasso processor, for those who are familiar with the Picasso processor. So like having 12 of those inside one Diablo. So one important note here is when the user's application is written to the flash of the Diablo16 from Workshop 4 IDE software, the user is able to choose the destination bank for the application to be stored in. So this is important. We can choose the bank for which our application has to be written and stored. Bank 0 is always the bank which is loaded and start up. That is Diablo's after the Diablo's. A Bank 0 application can then transfer control over to one of the other banks, and the application stored in there will then run. So using the 40GL flash run function, you can achieve the transferring of control from one bank to the other. Also, a single application cannot take up more than one bank itself. When an application from another bank running, using the flash run function, the processor is restarted. So it means the execution will be again from the beginning when you switch to bank. So it's like resetting the processor or restarting the execution of the program. Whatever the program is stored in that particular bank. So another feature is that an application what runs on one bank can store data on another bank using 40GL commands. So I won't go into the deeper part of this with the 40GL commands, but all these are described in the internal functions document of the Diablo16. And it's just a feature that if you are running your application from one bank, you can store data in another bank and pick up data from there. So now we go to the system and use the RAM. So this is also, you have a user RAM of 32 kilobytes and a system register and flag separate section for all internal processes. So the system RAM is reserved for the system and it's not accessible by the user. It is used for processes such as the audio buffer, intermediate file transfers, graphics rendering, etc. The RAM ensures the user's RAM is not taken by the system. So let's go to the next feature. It's the PmmC and Display driver section. Okay, in passing we were discussing this a while ago. I just want to point out a few more things about it. So all functionality, including the high-level commands, are built into the chip. The chip level configuration is available at PmmC. Okay, PmmC stands for Personality Module Microcode, which can be likened to traditional firmware. The Diablo16 processor has a display driver. Quite apart from this, the Picasso, which doesn't have. The display driver file is a separate file. And it stores specific display settings from the PmmC. So the display driver contains interfaces and parameters associated with the particular display that is to be connected to the Diablo16 processor. So the PmmC is in protected memory, and it cannot be read or damaged by network writes to the individual flash areas. That means even if you're right here, or maybe some errors here, the PmmC is not affected since it is in a protected area. At any time, you can update the PmmC, but this will not disturb whatever application is stored in the flash band. Okay, the internal functions are within the PmmC file, and there are over 450 of these built functions for graphics, sound, math functions, etc. So that means whenever you have a 40GL program running, you don't need to include this library. So you don't need the long compile time. Then all these functions are built in. Again, for a review of all the internal functions, you can always refer to the Diablo16 40GL internal functions document available for this processor, and which you can download from the website. Okay, here it's the mapping of the registers, internal. Well, there are about over 100 of it, so it is very important, especially when you are coding in 40GL and doing some register operations. So you have there the hex codes, the hex address, at the same time the decimal address. So all these registers are in there for the pin counter and pin event. And each of these addresses, they can be accessible via the PW and OW function. Okay, on the datasheet of the Diablo16, we have included a reference design. Actually, this is the schematic of one of the displays, that is the micro LCD sensitivity, which we will be discussing later on in more detail. But it's just to give you at least an overview of some circuits, what contains the Diablo processor, and how it can be interconnected. This is the display drive. Sorry, I didn't make a zoom view, but you can find it out in the datasheet, which can be downloaded as well. Okay. How to program the Diablo16? It's either we use the 4D programming table or the micro USB PA5 serial to USB adapter. They are essential for downloading the PmmCs or for programming your application to the flash. So now this one shows you the several of the Diablo16 display modules. What we have, this is the micro LCD 750. It is already being sold, and also this one, the micro LCD 35DT, it's very fresh in the market. Upcoming is the micro LCD 220 RD. It's a round display, actually perfect for instruments, instrumentation gauges, some meters, panels, and this kind of things. The next product is the OEM graphics module, which we call the OGM. So the Diablo 16 has an OGM module, and it's ideally suited for any high volume application design that requires a fast, low cost, and easy to implement display solution. Especially if you cannot accommodate the standard polysystem display module like what I have shown you, then you can customize. You can, this is attachable to the main board, to your application board. It's like an assembly module, so it's soldered via the connections here. It has already a header for the flex connector, and it can interface directly with the 2.4, 2.8, 2.2, and 3.2 inch-wide audio systems displays that we also sell separately. The Diablo 16 OGMs are subject to MOQ, so if you think you have a big application, you can always contact our sales and marketing for inquiries. Okay, the applications of this processor is limitless. Actually, most of these can be used for general purposes, embedded graphics, elevator control systems, point of sale terminals, electronic gauges and meters, test measurement and general purpose instrumentation, industrial control and robotics, automated system displays, GPS navigation systems, medical instruments and applications, home appliances and smart home automation, security and access control points, gaming equipment, aviation systems, HMI with touch panels. So all this, to name a few, and various others, whatever. It's where your imagination can lead you, and you can use this processor. So the second part of this webinar is going to be micro LCD 70dp, which is actually a Diablo 16 based product. So the micro LCD 70dp is designed for applications demanding a large intelligent display module, and it is the largest from 40 systems today. Driven by Diablo 16. It's very capable of a powerful suite which enables the standalone functionality program using the 40 systems workshop for IDE software. The workshop IDE enables graphic solutions to be constructed rapidly and with ease due to the design being solely for these graphic processors. So the features of the micro LCD 70dp is powerful 7-inch intelligent LCD TFT display module. It has an 800 by 480 resolution, RGB, and 65 to 2 live colors, TFT screen, integrated 4-wire assisted touch panel. It's easy piping interface to any CPL serial host, which we have also, like by the Picasso-based display. It uses the same configuration with this VCC, TX, RX, ground reset for the programming and for serially connecting the display to the application. Of course, you have 6 banks of 32 KB each of flash memory for user application flows of data, which I have discussed earlier when we were looking deeper into the Diablo 16 core. We have 32 kilobytes of SRAM purely for the user, 16 GPIOs for the user interfacing, which include 4 configurable analog inputs, I have also indicated earlier when I was discussing about the GPIO concept. So the GPIO is variously configurable for this display for alternative functions such as 3 times I2C one-time SPI, the state for the SD card, and of course configurable SPI channels available and configurable. STTL serial COM ports available. Up to 6 GPIOs can be used as pin counters, up to 6 GPIOs for pulse-based modulation and applications to be used for simple systems using motors and all this kind of stuff. You have up to 10 GPIOs for pulse output. You have up to 14 GPIOs can be configured for processor and other inputs. We have shown this earlier. So the micro LCD 70DT also has onboard micro SD memory card connector for multimedia storage and data level purposes. So it's when you use a full-sided SD memory card, the connector is available for volume purchases. You have a DOS-compatible file access, the FAT16 format, as well as low-level access to card format. So you have a dedicated raw pulse width modulation audio driven by WAV files from the micro SD card. It has onboard audio amplifier with a tiny 8-ohm speaker for sound generation. Here you cannot see it here, but from another view, we can. It can display full color images, animations, icons, video clips, and frozen 4D systems displays. It supports also all available Windows fonts. So it can be powered off from 4 volts to 5.5 volt range operations. The module dimensions are this. Display viewing area is this in mm. So, and you have 4 mechanical mounting holes. So for programming the micro LCD 70DT, you either use a 4D programming tool or the micro USB A5. And of course, you need to download and install the workshop for IDE software. And using that, you can use either Designer, VC, Genie, or serial environments for developing your application. So to assist with the development of 43L application workshop for IDE combines a full-featured editor, compiler, linker, and a downloader into a single piece-based application. All you need to code, test, run your application. So 40GL is available to be written in 2 of the 4 environments, namely Designer and VC. So that's pretty much the same like the Picasso. Genie is completely programming without any code. 40GL code is generated in the background. And of course, Serial is a plain slave display configuration where the host sends commands, SPE serial commands to the display in order to show images or text, strings, or whatever on screen. So to get you started, there are application notes on our website. So on our banner, you can find the application notes link. And the topics are classified into this classification. The D stands for Diablo, so for the D1XXX is for general topics. If you see a D2XXX, then it's for designer. And 3XXX for VC, 4XXX for VCG, and 5XXX for serial. This is what you see actually on the website. So you have here some written for general, designer, VCG name. We have not done any serial application notes for the 70 DP. However, you can do as well any of the Picasso application notes. It works as well with the Diablo 16. So you can see this, the PDF here, the icons here are, we download the application note. The zip files, the zip icons here are the project files. Whatever project is discussed inside the application note are all provided on the zip file. So for you who wants to go step by step through any of these topics, there are more. I just was taking captions of our website. There are over 100 topics here to choose from. And they were designed in a way that it's easy for every user to understand. So every beginner, even a beginner who hasn't any experience with the Picasso or other processors what we have, can go right away to use the Diablo processor, and you have guides here via our application note. Okay, let me discuss a bit what you will normally do as you get out the module or device from the package, from the box. Can be any display. In particular, let's say for the micro LCD 70DC. So to power up and connect to a computer using the micro USB A5, step one, you have to connect one end of the 5-way email cable to your module program counter connector. Sorry, following the orientation on both cable and module cables. So make sure that these labels correspond to the labels on the board, except of course it's RX and DX. It is interchanged, and the ground to ground the reset to the reset. So you have to connect the 5-pin header to the other end of the 5-way cable. This will allow you to connect the cable with the micro USB A5. So after that, on the other end of the micro USB A5, you can connect a mini USB adapter, and the other end you can connect to your laptop or PC. So next, to power up and connect to a computer using the 40 programming cable. So in case you have the 40 programming cable, it's straightforward. You connect one end, the header end has to be connected to the board. Again, make sure the labels are correct, and the other end connected to the PC. So you open your workshop for I2C, assuming it has been installed already, and you have to select the display. In this case, we're talking about the micro LCD 70DC. So that's step 2, and then it allows you to select also the orientation, portrait, reverse portrait, landscape, or reverse landscape. Then you click next, which will bring you to the selection of the environment. So whether it's up to you, or it depends also on your level of expertise, whether you want to go to designer, to VC, to VC Genie or Imperial. Genie, as I have told you earlier, doesn't require any 40GL coding. Serial, you have to be familiar with the internal functions, at least, especially the SPI command, which are essentially also the internal functions. Definitely for designer and lead pure coding, VC is an interactive environment. Partly it's object-oriented and partly you can enter code. So whatever you cannot do in any environment, you can do it in VC. You can fully customize the behavior of objects, and including also how to talk with them, how to communicate with them. So you have to click the com stub. The com stub will let you see the status of the communication between the display and the PC. So if the com dot, assuming you have selected the proper com port, if the dot is blue, then there's no need to do anything else. That means Workshop 4 has recognized the micro LCD 70DC. It should display actually on the side of the ribbon. You will see also the model and as well as the PmmC and display driver version. I just don't indicate it here for simplicity. So, and next, after checking the status of the COM that is connected, if the dot is red, of course, you just have to connect, select the proper COM port, click the red dot, and this will display yellow dot shortly, and then it becomes blue if it has established connection with the micro LCD 70DC or whatever display what is connected. So clicking the home button will bring you back to the editor, the main editor. So this I was explaining earlier is in case you get the home dot instead of blue, if it's red. So clicking it will turn to yellow and then blue. Okay, the Diablo 16 base display needs to be loaded not only with PmmC but also with the display driver. To do that, it's best to select when you open up the PmmC loader window, you have to click manual and first select your COM port if it's not yet detected or displayed. And you have to browse for your PmmC. So this is the PmmC file, the latest one, and the driver file as well. So, and after that, you click load, and it should load the PmmC and the driver. You get the status here written as you proceed, and the progress bar advances as well. So after programming is successful, it displays on screen. So you can click close after that. So ladies and gentlemen, that ends our presentation this afternoon or this morning. And so if you have any questions, you can let me know, and I'll try to answer it.
Okay, if there is any question, please write it to Q&A answer so we can answer it. But so far, I can see any question. Anyway, I use this time. If there is somebody who would like to write, please do it so right now. So I only now will thank you, Danny, for your presentation. If there is any question also after this webinar, you can feel free to contact us and write this question, and we will pass it to Danny so you get your answer for your question. So Danny, thank you one more time for your presentation. We don't have any questions, so I think we can go ahead. If there is anything from you would like to say, or is all?
Okay, I would like to thank also everyone who participated in this webinar. Thank you very much, Mima, for the opportunity given for us. So,
Okay, so but we have one question right now. It's the programming language is similar to Pascal. Will be there possibility to program this module with something similar to C? Danny? Can you hear me, Danny?
I can hear you.
Yes.
Right. And so, as I said, the for DGL, it's very close to C, and it has features of the C language. However, for programming the display modules, like the Diablo16 micro LCD, 7DT, and all other 4D products, it has to use 4DGL, which is the 4D graphics language optimized to work with the display products. And to be able to learn about it, we have documentation available to our website. You have to go through the WordCamp 4 IDE product page. Under that, you can there are links in the download section where you can download all the documentation about 4DGL programming, the reference manual, internal functions, and all this kind of thing.
Okay, thank you for your answer. So we got a couple more questions. The other question is, what is the resolution of the analog inputs?
What is the resolution of?
Of the analog input. Audio. You can also see this question then in this window, Q&A window on your right side.
Hold on, I have to check. Oh, where is it?
In general, analog digital to converter. What is the resolution?
The analog pins? Hold on. Are you referring to the analog input? Hello, Mima.
Okay, I will copy the
I can't see the question, but anyway, for the analog inputs, we have there a digital analog converter inside. It has it's a 12-bit analog to digital converter. So, and it has a capacity of reading about 40K values per second, and it's 12 bits. It's the resolution. So it has a range of 0 to 3.3 volts. Do I answer the question, or have I incorrectly understood it?
How many bits does it have? What is the resolution?
12 bits.
How many bits?
12.
1,000. 12.
12 bits.
Okay, you did answer the question now. Okay, so let me see. Yeah, there is another question. Hold on, please. Is there a way to enable multiply events for given button slider when programming with VZGenie? Have the display both update LED digit and output to serial?
Can you repeat the question again, please? Is there a way to?
Okay, I write it down for you so you can see it now.
Oh, is there a way to enable multiple events for a given button or slider when programming with VZGenie? No, okay. You can select one of two events, that is either using the on-changing or on-change event. Let's say you have a button, so you can assign an on-changing event, for instance, to one object, and you can assign the on-change event to a different object as well, or you can report it to the external application board in case you have an external host or microcontroller that's connected. So,
okay, so thank you for the answer. And the next question is it possible to create a buffer from the screen and then update the screen instantly? This to make screen switching faster. Now with the Picasso we can see it building up from top to bottom.
well, this is we have there actually one of the features I have discussed earlier. We are referring to the writing of the screens. Well, we don't have that buffering actually. However, it depends on the application. Whether if you are streaming, video, it's very slow. It would be very slow. Although it's still the Diablo is faster than the Picasso, so it depends on what resolution you have on screen. If you have an image that is small, then of course you can refresh at a faster rate. But if you take, for instance, the 70dp, the full screen, which is the full resolution of 800 by 480, and you update it, well, it all depends on your application actually, and I can say it won't be nice for streaming video, and it is not constructed for that. So even with its current speed, it should be in the range of less than 2 frames per second. If you take 1 one frame after they are in full resolution. But of course, as I have said, it all depends on the kind of resolution that you have on the picture. So if the picture is smaller and occupies only a fourth or a third of the display, then of course it's faster to refresh it.
Okay. I cannot see any other question. Let me thank you for the presentation one more time, and also thank you everybody for attending our webinar. Hopefully it was useful for you, and you learned some new useful information. So at the end, I would like to remind you a short survey at the end of this webinar. So if you can please fulfill it for us and give us your feedback about it, we will be really thankful, and one of you can win a programming cable from 4D Systems. So thank you one more time. Also, you can find this presentation online on our website. Probably next week it will be already online. And also, I would like to invite you to our next webinar, which will be next Wednesday, also at 10 o'clock, and it will be for embedded artists. So one more time, thank you everybody for joining, and have a nice day.
Okay, welcome. Thank you very much, everyone.
Okay.